Okay, so let's jump right in. We're going to explore a world that's so ridiculously small it's almost impossible to even picture. But believe me, it's already changing, well, pretty much everything. And it all starts with a simple little puzzle you might find in your own backyard.
So here's a weird one for you. Have you ever wondered why, if you pour something super sticky like honey onto a lotus leaf, it just beads up and rolls right off, clean as a whistle? But if you try that with a piece of paper, you get a sticky mess. What is the lotus leaf's secret?
Well, it turns out the answer is completely invisible. If you could zoom in, and I mean way in, thousands of times closer, you'd see that the leaf's surface is covered in these tiny, waxy, hairy bumps. These are nanostructures, and they're the magic behind this lotus effect. And they're the key to this entire explainer.
So, what are we really talking about when we say nano? Let's get our heads around just how small this invisible world actually is.
Okay, so officially, a nanomaterial is anything that has at least one dimension measuring between 1 and 100 nanometers. And the name itself, it comes from the Greek word nanos, which means dwarf. Kind of fitting, right?
But how small is that? Really? It's this weird middle ground. Bigger than an atom, but way, way smaller than even a single red blood cell. To really put it in perspective, get your head around this analogy. A nanometer is to a softball what that same softball is to the entire planet Earth. Yeah, that's the mind-bending scale we're operating on.
All right, so it's small. Big deal, right? Well, actually, yes, it's a huge deal. Because here's the crucial thing. When stuff gets that small, the normal rules of physics and chemistry they start to change, and materials begin to behave in totally new, almost magical ways.
And to see what I mean, let's just take one of the most common elements there is, carbon. You might think you know carbon, but at the nanoscale, it's a completely different beast.
Check this out. Everything on this table is made of the exact same thing, carbon atoms. The only thing that's different is how those atoms are arranged. In its regular, bulk form, you get things like diamond, the hardest stuff we know, or the soft graphite in your pencil. But when you rearrange those same exact atoms at the nanoscale, you get a whole new family of materials.
If you can arrange those carbon atoms into a flat sheet that's just one single atom thick, you get graphene. It is literally the thinnest material ever created, and it's also one of the strongest. And the craziest part, it was first isolated by scientists back in 2004 using, you ready for this? A chunk of graphite and some Scotch tape. Seriously, that's it. Now take that same sheet of graphene and roll it up into a tiny, seamless cylinder. What you have now is a carbon nanotube. And this is where the properties just get insane. A carbon nanotube is about 100 times stronger than steel, but it weighs only a sixth as much. We're talking about a true supermaterial. So the obvious question is, why? Right? Why does just changing the size and the arrangement of atoms have such a dramatic, unbelievable effect? Well, it really boils down to two main reasons. The first one's called the surface effect. Think about it this way. In a big block of something, most of the atoms are buried deep inside. But as you shrink it down to the nano level, a much, much higher percentage of its atoms are right there on the surface, exposed to the world. This makes nanomaterials way more reactive than their big brothers. The second reason is, well, it's a lot weirder. It's called the quantum effect. Down at this tiny scale, the physics we see every day just doesn't apply anymore. The strange, spooky rules of quantum mechanics take over. And that changes everything. A material's color, how well it conducts electricity, its melting point. It was the legendary physicist Richard Feynman who saw this all coming, way back in 1959, when he famously said, "There's plenty of room at the bottom for us to build and create." Which of course leads to another massive question. If this stuff is smaller than a wavelength of light, how in the world did we ever manage to see it, let alone start playing around with it?
See, here's the fundamental problem. You can't see something with a tool that's bigger than the object you're trying to look at. And since nanomaterials are smaller than the wavelengths of visible light, a normal light microscope is just blind to them. It's not a matter of making a better lens, it's physically impossible.
So to get around that, scientists had to invent completely new ways of seeing. You've got things like the transmission electron microscope, or TEM, which shoots a beam of electrons through a super thin sample to see its insides. And then you have the scanning tunneling microscope, or STM, which uses this impossibly tiny probe to basically feel the surface of a sample one atom at a time. And this is where it gets just wild. That STM doesn't just let us see individual atoms, it lets us move them. This image you're looking at isn't a drawing. It's a single frame from the world's smallest movie,
called A Boy and His Atom. Scientists at IBM made it by literally picking up individual molecules and putting them where they wanted them. This is the ultimate control over matter.
So we can see and even control the very building blocks of our universe. The next question is, what can we actually do with this incredible new power? Let's look at the applications that are already here and what's coming next.
In medicine, the dream is straight out of science fiction. We're talking about creating nanorobots that could swim through our bloodstream, delivering drugs to zap cancer cells while leaving healthy cells totally alone, or even performing tiny repairs from inside our bodies.
But you don't have to look to the future. Nanotechnology is already all around you. Remember that lotus effect? We've already copied it to make stain-proof fabrics and self-cleaning windows. And hey, if you've ever used a sunscreen that rubs in clear instead of leaving you chalky and white, that's because it uses transparent nanoparticles to block UV rays.
Nanotech also has huge potential for the environment. Think about it. Those super strong, super light carbon nanotubes could be used to build bigger, lighter, more efficient wind turbine blades. And we can use other nanoparticles as tiny little scrubbers to help purify our air and water.
But, as with any powerful new technology, this incredible promise also comes with some very serious questions that we absolutely have to ask ourselves.
We have to think about the other side of the coin. What are the long-term health risks if these tiny, tiny particles get into our lungs or our bloodstream? Could they build up in the environment and become a new kind of pollutant? These are really important questions that scientists are working on right now, because being responsible is just as crucial as being innovative.
The nano revolution isn't some far-off sci-fi future. It is happening right now. We are gaining the ability to build our world from the bottom up, one atom at a time. The real challenge for all of us is to figure out how to use this incredible power wisely to make sure we build that new future responsibly. You have to wonder, what's the next big thing that's going to come from thinking this small?